Hey, geometry friends, here we are in chapter 1, still looking at chapter 1, but we're in section 5, and today we'll discuss angle relationships. Our vocabulary today helps us focus in on some concepts and some ways angles relate to one another. So please definitely take note, draw little pictures to give yourself a visual representation of each of the things we talk about. So, adjacent angles are angles that share a side. So they share a side and a vertex. So if I refer to this angle here, let's call this vertex B and this A and C, and let's call this D. I can tell you that, let me make these rays. I can tell you that angle ABC is adjacent to angle CBD. Yes, it's CBD. So angle ABC is adjacent to angle CBD. And I don't know of any symbol that they use to say adjacent angles. So we'll just say that angles ABC and CBD are adjacent. They share a common side, a vertex and a common side. All right, so a linear pair. A linear pair refers to adjacent angles that particularly form a line, right? So here's a line, and this line is formed by the addition of these two angles. I'm going to be a little lazy here, call this angle 1 and call this angle 2. So angles 1 and angle 2 are a linear pair, right? They're not equivalent angles, but angle 1 and angle 2, they're linear pairs. Let me use a little color to help be distinctive about what we're talking about. So this thing highlighted in red would be a linear pair. So linear pair has the quality of being adjacent angles that form a straight line. And a little bit of extra information, adjacent angles that form a straight line, I'm thinking you might know this. This is a 180-degree angle. The sum of these two angles would be 180 degrees, and we're going to have another definition for that. All right, so now we've got this concept of vertical angles. And vertical angles, sometimes I like to call it bow tie angles, right? Because vertical angles look like this. They're formed by the intersection of two lines. And let's call this angle 7 and angle 8. Angle 7 and angle 8 are vertical angles. They are opposite one another. And also, let's do this, 9 and 10. 9 and 10 are vertical angles. So I see a bow tie in this, so sometimes I call vertical angles bow ties. But vertical angles are opposite one another. There are two opposite angles that are formed when two lines intersect. They are not adjacent, however, right? They do not share a side. They're opposite one another. And the cool thing about vertical angles is that vertical angles are always equal. They're always congruent. Vertical angles are congruent. So 7 and 8, whatever measure 7 is, 8 has, whatever measure 9 has, 10 has. And so I'll also highlight this in green here, so you know that this represents vertical angles. And so angles 7 and 8 and angles 9 and 10 are pairs of vertical angles. All right, so we're going to talk about complementary angles. And these angles come together to complement each other. Talk about their hair. No, these angles come together. I'm sorry, I'm corny. These angles come together and they are two angles, right? Anytime you have two angles whose sum is 90 degrees, all right? So if you have two angles, if I'm walking down the street and I see this angle over here, and the measure of this angle is 41 degrees, and the measure of this angle over here happens to be 49 degrees, I know that these are complementary angles. They're complementary angles because the sum of the two angles add up to 90 degrees. And so sometimes you'll see complementary angles in that situation, or you might see complementary angles being adjacent to one another, meaning side by side sharing a ray, and fitting together to form that noticeable and detectable 90-degree angle. So I might have, I can look at these two angles here. Let's call this vertex C, let's call this D, and this point E and F. I can say that, that's not an F, I can say that angle DCE and angles ECF are complementary just by the fact that I see when you put them together, they're going to make a 90-degree angle. So the sums might add up to 90 degrees and they may not be adjacent, or they might actually fit together to form a 90-degree angle, so I can visually see that they are complementary. And I'll highlight that in purple and also highlight this part of the notes to say that we've got these complementary angles here. So complementary angles are two angles that add up to 90 degrees. And so the next type of angle we're going to discuss, let me highlight these. The next type of angle are supplementary angles. So supplementary angles again refer to two angles whose sum, when you add them up, add up to 60 plus 120, 180 degrees. So supplementary angles and linear pairs are supplementary angles. That's the key point here. So when I have two angles that add up to 180 degrees, those angles are considered supplements of each other or supplementary. So anytime I have this situation here, wrong marker. Anytime I have two angles like these guys that add up to 180 degrees, or I'm going to circle this situation here because this also applies to supplementary angles. Two angles that add up to 180 degrees, whether I see it adding up to 180 degrees because they form a line, or whether I can tell by their angle measures, they are both considered supplementary. And our final concept today that we're going to talk about is one that we've seen but not actually discussed, is perpendicular. So a line that crosses another line, or even a segment that crosses another segment, where they intersect and they form a 90-degree angle, these guys are referred to as perpendicular lines. These are perpendicular lines. So here's the word perpendicular. I'm going to highlight this. Perpendicular lines or perpendicular means two things that intersect to form a 90-degree angle. Could be lines, could be segments, could be rays, but perpendicular means forming a 90-degree angle. Okay, so here we have what they're calling in the textbook a real world example, because they used a model of real people and put a drawing on top. Okay, so name an angle pair that satisfies each condition. So let's take a look. Two acute adjacent angles. Well, we've got two terms that we need to remember there. One term is acute and the other is adjacent. So if you remember from the last chapter, or last section rather, acute angles are angles that are less than 90 degrees. And quite honestly, many of these look like they're less than 90 degrees, and we want them to be adjacent, meaning they have the same side. They share one of the same rays. So I'm just going to highlight, let me use black, and I'm going to say, well, this would be a perfect example. This little guy is clearly less than 90 degrees, and it shares the side with this guy that's less than 90 degrees. Obviously, there's more than one answer. We could have done this one and this one, which we're doing, or this one and this one, but let's name the two that we did. So the two we have are angle OJN, and angle NJM. This next one, we have two obtuse vertical angles. Now, we remember the word obtuse refers to angles that are greater than 90 degrees, and vertical angles are those angles that are, call them bow tie angles, angles that are across from one another, like this guy and this guy. Those are vertical angles, and this one, those are vertical angles. So with that in mind, we need obtuse angles that are formed by an X, two things intersecting each other. And let me take off some of what I've already done here and take a look. We can see that this angle here and this angle here, it looks like it's a little bit twisted. So here's what I'm going to do. I'm going to trace what I'm going to call the line, and it looks like this angle, this segment rather, goes like this, and this other segment goes like this. So I think the proper angle that we'd have to choose would be KJM and angles HJN. As I look at this, I think it would have been a mistake to call KJL and HJO vertical angles, because it looks like the two lines don't actually create them. Yeah, it doesn't look like they create them. All right, let's go ahead and take a look at this next example. Example 2, angle measures. It says, find the measure of two supplementary angles in the find the measure of two supplementary angles if the difference in the measures of the two angles is 18. Well, what I know is two angles that are supplementary by definition, let's say one is angle X and the other is angle Y. I know that the measure of angle X and the measure of angle Y must both add up to 180 degrees. Okay, so I'm going to assume that X and Y are my two supplementary angles. But then I find out that the difference of these two angles, meaning let's say X is the bigger one, the measure of angle X minus that measure of angle Y is going to give me 18. And now I got to figure out what to do. If you remember back in algebra, you had X plus Y equals maybe a number, 180, and X minus Y is equal to a number like 18. We would call this a system of linear equations. And what we'd be called to do is try to figure out the X and Y value that satisfies both of these equations at the same time. How we do this, we had a number of ways we did it in algebra. You might remember graphing or substitution or elimination. I'm going to do elimination just because it's easier. If you find that you've forgotten these and you need to chit chat with me about it, awesome, let's do it. Just tell me I do not remember linear systems of equations. We should talk about it and do that. Assuming that you do remember that, elimination says as long as you line up the problem completely, x's over x's, y's over y's, equal sign, operation sign, and answers over one another, you can literally add or subtract the problems. And I'm going to do that here because these are opposite signs and nice things happen when you have that. So if I add these two together, I get 2x, the y's cancel out, is equal to 198. And the beauty in that is now I've lost one variable and I can solve this pretty easily. And we get that x is equal to 99. And with that in mind, we now have the power to solve for y. So if x is equal to 99, and I go back to either one of the original equations, then I can substitute 99 in here. 99 plus y is equal to 180. You guys see where this is going. And then with a little bit of subtraction on both sides, we get that y is equal to, anybody? Can you think of it? Y is equal to 81. All right, so now we've solved this and we can see, yes, indeed, if this angle is 99 and this angle is 81, it satisfies the condition that they are supplementary. And if this angle is 99 and this is 81, it satisfies the condition that the difference between the two angles would be 18. Okay, so example 3, we're looking at perpendicular lines. So find x and y so that the line PR and line SQ are perpendicular. So let's take a look. If line PR and line SQ are perpendicular, that's these two. Let me highlight them a little bit, keep my focus on them, PR and SQ. Then what that means is that this angle here would be 90 degrees. This would be 90. These two over here would add up to 90 degrees, right? So that's what that tells me. So if PR is perpendicular to SQ, then STR is 90 degrees, and angle PTQ would be 90 degrees. Okay, so that's good information to know. So I've got this angle is 90, this angle is 90. We've got to find the variables that's going to make that true. Hopefully you see the equations we need to set up. We have 4y minus 2 equals 90, right? And then the sum of these two angles, 2x plus 5x plus 6 equals 90. And just showing off a little bit of our algebra skills, we can see that we would add 2 to both sides. We can see that our answer for y would be 23. And with a bit of algebraic manipulation over here, 2x and 5x gives me 7x, plus 6 gives me 90, subtract 6 on both sides. I get that 7x is equal to 84, and I think if I remember correctly, x must be equal to 12. So y equals 23 and x is equal to 12. Let's look at another example. In this example, we're going to determine if these statements are true given the picture. So KHJ, can KHJ and GHM be complementary? Complementary means that when I add them up, I get 90 degrees. I see this is 90 degrees, but I have no real information to determine that, so I'm going to go with a no here. Here is GHK, GHK, that's this angle here, and JHK, a linear pair, and the answer is yes. because we can see that they form a straight line. And finally is HL, that's this segment here, is HL, I should say ray rather, is that perpendicular to HM? And we can say yes, given that symbol there. All right, let me know if you have